Did cylinder plus cylinder in a perpendicular relation, he got a square. And Lazia did, what did you do?
Cylinder plus Mobius.
Mobius, okay. And he got a square. I did Mobius bend clockwise plus Mobius bend counterclockwise. I got a link tart.
Yeah, that's so romantic, I know, right?
So today we're going to be talking about something that we touched upon actually on the first day of class, which is what happens when you cut certain objects such as cylinders or Mobius strips with 1/2 width, 1/3 width, 1/4 width, but we're going to put a little spin on it. Instead of just having one of these objects, we're actually going to be gluing them together in various orientations and seeing what the results are going to be. So, allow us then to start off with a simple case where you have a cylinder glued perpendicular to another cylinder. In this case, what might you think the result will be? Let's see. So, cutting this, right, if we cut it halfway for each of these, we get a very interesting result here, where if you unfold it, after we make this final cut, you get this, a square. Now, how did that happen?
In this activity, our goal will be to put together a cylinder and a Mobius strip.
Okay, so I'm going to start by cutting my paper in the middle. Okay, you can do it with scissors or just do it by hand like I'm doing now. I'm more comfortable with that. I'm going to cut the paper in the middle once, and the other part also in the middle, because I'm going to cut it. Make sure that they don't separate when I cut it. So now after I glue the two strips together, I'm going to form a cylinder. My first cylinder right here, just like that. And make sure that I glue it properly in the front and also in the back. Just turn it. It doesn't matter clockwise or counterclockwise. I turn it only once and you glue it inside. Okay, now this is what I have. A nice cylinder here and a Mobius strip glued to a Mobius strip right here. So now, what do you think are we going to get if we cut the cylinder in the middle and the Mobius strip also in the middle? I want you to take a guess. You can pause the video for a second and try it yourself. Okay, if you're done now, we're going to do it together. I'm going to cut mine. Start right here at the center of the strap. Okay, right here, our strap and two end cuff. Okay, opposite to each other. I'm going to cut now the strap in the middle. So let's see now what we're going to get.
I unfold it on both sides and lay it on my table, and we can see
a nice small square. Okay, you can see it. The sides are the same. Right.
Valentine did cylinder and cylinder. He put perpendicular to both cylinders. When he cut it in the middle, he got a square. Lazia did it the cylinder and a Mobius strip. He put them together in perpendicular to each other, and he gave a square. Now let's do one more experiment. This time I'm going to do no cylinder to cylinder or cylinder to Mobius strip. I'm going to put two Mobius strip perpendicular to each other. One would be clockwise, one would be counterclockwise. But before I do that, I want you to make a prediction. I want you to pause the video and think, what would I get? Would I get a square or would I get something else? Alright. Now, if you get stuck, definitely you can take a look. So what I do, A4 paper, and I'm going to cut it in the middle, just like Lazier and Valentine did. And as Lazier, I like to use my hand and even sometimes tongue. Okay, I don't need it. Okay, so this is 100% hands-on. So I'm gonna have two nice equal size strips. So this is exactly what you saw before with Lazier. Now I'm going to put them together and I'm going to glue them in the middle. What you saw before with Lazier, he has this, and Valentine also have that. Now what I'm going to do, I'm going to do two movie sticks. One is clockwise, one is counterclockwise. That's why you have to be very careful. For Lazier time, the clockwise, counterclockwise doesn't matter, but this time is very important. So first one, I'm going to just keep the thing in track so I don't make mistake. This is a cylinder, so I'm going to put a dot over here at the end, and you have to look at very carefully. So I'm going to twist the dot, so the mirror image of the dot would be on the top. So this is one movie stick. This time I'm going to put the dot on the top. So last time I put a dot on the bottom. Now this time I'm going to put a dot on the top. If you make one little mistake, you're not going to get the correct result that you're looking for. So I put the dot on the top. Now it is cylinder, I'm going to make it a Mobius band. So the mirror image of the dot is on the bottom right now. So yeah, you have to pay attention to this this small thing, otherwise you're not going to get the expected result. Alright, now what I have two Mobius band. One is clockwise, one is counterclockwise. Now I want you to pause video for the second time and make a prediction. Okay? Alright, now let's see what happens. What are we gonna get? Are we going to get a square? Are we going to get something else? Maybe we're gonna get something else very beautiful, much beautiful than a square. So cutting Mobius strip is not easy, so sometimes you have to pleat them. Cut. Keep cutting. Keep cutting. Let's see whether I'll get a two lintard that I'm supposed to get. Yes, two lintard. We got two lintard. Isn't it beautiful? Two Mobius bands, one clockwise, one counterclockwise, gives us two lintard.
So romantic.
Guys, we're gonna assign you some homework.
Okay, counterclockwise.
What did you get? Alright.
Counterclockwise and counterclockwise
Oh
also.
yeah. Counterclockwise plus Mobius band counterclockwise. Yeah.
In this one, I kind of cut both of them at the same time, and then didn't really show you guys what happened with the intermediate cuts. So let's try this again with here, but let's not actually cut this section right here where they're connected together. So see, we're going to leave that piece to the very end. If we keep cutting like this, they're going to be forming 90-degree angles, and they're going to be 4 of them. So just right off the bat, we can kind of figure that whatever shape comes out of this is going to have 4 90-degree angles somehow. So now, if we make the cut one at a time, we get something interesting like this, where we have our 2 bands, right, as we expect, but then the 2 bands are being connected by 2 separate strips based on how we cut it. So from there, then, we can observe that there's one 90-degree angle, a second, and then 2 more down at the bottom here. Right here, left and right. And so, in that case, then, if we finish off the 2 cuts, we can kind of see what's going to happen. These bands are going to unwrap, because now they're going to be cut. So this one unwraps. Right, this end is now unwrapped. And this one will also unwrap into the square that we kind of see below. So, now that's all very interesting and good, that we have 90-degree angles like that. So, I want to actually posit a question here. What would happen if we, instead of having them perpendicular to each other, change the angle? So, this is a very similar setup where you have 2 cylinders, but one of them is very distinctly at a different angle. It's not 90. See what you guys come up with. Let me know. This one will do at a future date. Okay, but now since we added an extra cylinder, why don't we just go further? Why don't we do something like this? So instead of 2, we've added 3 in a 90-degree orientation. And just like before, we're going to cut them in sort of a 50, like cut them halfway. So doing that. Also going to save the final cuts for the end so that you guys can take a look at the magic a little bit and see how this trick unfolds. Oh, we seem to have lost something. Okay, so now we have this here. But that doesn't look like 3 pieces of paper put together. What happened to the other one? Oh, well, it's here. So when we put 3 together, we have 2 smaller rectangles. Now, why might that be? Well, if you think about what we have there, right? 2 pieces of paper put together will give us 4 right angles. And then if we add the third one, the third cylinder, we would then naturally create another set of 4 right angles at the connection point. So with that, we can see where the right angles come from. But then why do they separate like that? This I'll leave as an exercise to the viewer. Now, we'll do one more. And then we'll give you some extra problems to kind of think about it in your mind. We'll go back now to our basic orientation here. But what now would happen, instead of cutting it in half, we cut it along the third lines. So cut this into 1/3, cut this into 1/3. Well, let's take a look. Things are getting a little difficult to hold now. I wonder. So, now we've cut it into 1/3, and wouldn't you know, something went a little bit awry, but these are actually supposed to be a little bit together, but they would kind of look like this, where we get our square, but if we then compare this square, we see some differences between that square and the square we got from the original. Now, these 2 squares have the same dimensions, length and width-wise, but the thickness of their border seems to be a little bit different. The one we just cut was a little bit thinner. That makes sense because it's a 1/3, but then what happened to the rest of the border? Went to something like this. So, tape didn't quite hold for this, but it ends up looking a little bit curved like this. So it's almost like a hollowed out boat. Not very effective for floating, but a really cool design nonetheless. So, now, why might that be? I'll also leave that to the reader. So far we've had that, the 2 cylinders cut into thirds, 2 cylinders cut into halves, and then the 3 cylinders that are 90 degrees to each other that we've demonstrated. couple more exercises that would be very fun for you guys to do is the one that I had mentioned previously for this one, where you have two cylinders connected at non-90 degree angles. And then also this one. What would happen if you stuck three cylinders together, but one of them was oriented not in 90 degrees? So, you guys can all have fun thinking about that.